morning, good afternoon to our audience. It's an absolute pleasure to introduce our special guest today, Andrea Krupa. She is President, CEO of PhotoSat. She's recognized as one of the Women's Executive Network's top 100 most powerful women in Canada. An absolute pleasure having you here with us, Andrea. Please, if you could do a quick introduction, tell us a little bit about what you do at PhotoSat.
Yeah, great. So thank you very much for having me. It's an
Of
honor.
course.
I appreciate it. And yeah, so at PhotoSat, we're a geospatial technology company. So essentially what we do is we take data from satellites, all kinds of data from all kinds of satellites, and make it mean something that is more
Mhm.
than just data and code, right? So we essentially create the software, we create the algorithms, we work with the mining industry to develop actionable data for the industry, primarily focused in mining, but not exclusively.
Actionable data. Great. And we can dive into that and how you make it actionable. But I'd love to ask first about a little bit about your background. How did you find yourself as president CEO of this company? What is your background and if there's a passion behind it as well?
Yeah, for sure. So PhotoSet was actually founded by my father. It was founded by my father in 1993. And growing up, I had very little interest in PhotoSat.
All right.
I ended up going into engineering, leaving engineering in third year, going into psychology, getting my master's in psychology, and thought I had a completely different life. And then I started mountain guiding and realized I really love maps. I really like maps. I really like
Right.
geology. I had a little bit
Exploring.
more of yeah, I had a little bit more of my father in me than I realized. And I actually had a company at the time. The first company that I started at the time was doing leadership development, group dynamics, working with National Resource Canada, Electronic Arts, these kind of big companies, and helping their leadership teams build effective, highly efficient teams. And that was something that I had started to do in the guiding world. And so when I came into PhotoSat, I actually came in because my father asked me to come in and help with the company, to come in and help with some of the teams, some of the things that were going on, improve the culture.
Pretty good move.
My first 6 months, I probably facilitated 300 meetings between one-on-ones, conflict resolution sessions, team building sessions, group dynamic sessions, leadership development, coaching, all of these things. And spending that much time in this company, I realized I actually really love it. Right? I
Right.
really love the company. I really love what we do. That was over 10 years ago now. Yeah, that's kind of
It's
how I came
incredible.
in. It was a lot of fun and not something 15 years ago I thought I would be doing. All my summer jobs growing up were working for PhotoSat. My first job ever, I was riding a bicycle around downtown Vancouver delivering tubes of maps to junior mining companies in the city. And so I knew a lot about the company, but really realized I had a passion for it once I came in.
Right. And that's something that can be seen like pretty frequently, where we all when we're growing, still trying to figure out like what we want to do, like we never really understand what it is like our parents do or anything like that, but it's all embedded, in their teachings and education and the passion that you have, you came just down the line and just kind of fell all into place. And now you guys are doing amazing things in the mining and geospatial industry. How are we building things that actually matter in these industries?
So, I mean, I think one of the core tenets of Photosat has always been building things for problems that people have. And that sounds really intuitive, but it's amazing how many people build, it's like that old in that movie, build it, if you build it, they will come. A lot of companies, especially
Right.
in the geospatial and satellite world, have this idea that, oh, well, this is cool. So if we build it, someone will find a use for it. And that's not the approach that we've ever taken at PhotoSat. Um, my father was a geophysicist, right, is a geophysicist, mining exploration geophysicist, and then oil and gas exploration geophysicist, probably 40 years of what he calls mud on his boots, right? We
Okay.
we came from this place of a deep understanding of what the problems people were trying to solve are, and that's how we've approached it. So we'll partner with customers, these really great, long-standing, trusted customers that will say, hey, this is a problem we have. Can you do something to fix it? Is there a solution that you can provide? And by doing that and actually developing things with the customer in mind and in consultation with the customer, we've been able to have actually a great deal of influence because we're fundamentally doing something different, even though it seems like what everyone should be doing. We're doing something different than what's normally happening, which puts us in a place of significant influence with our customers and with the market because we know what's going on.
We can't start with like the tech first or these advanced solutions and then go try to sell it to someone else. We got to start with the people first, work our way back to the solution. It has to be tailored, and especially with these mining operations, and there's so much risk and so much that they need. So, how does photosats, satellite data and imagery help mining operations either reduce risk or error? How are we bridging the gap between, well, space technology and real mining needs?
The mining industry is sort of separated into a few different areas, right? You have your mining exploration, you have your operations, and you have your closure reclamation. There's more
Right.
complicated than that, but those are the life cycle of the
High
mine
level.
and a high level life
Yeah.
cycle. And I think the different areas have different risk tolerances, right? Exploration, high risk tolerance. Operations, very, very low risk tolerance, and reclamation also more on the lower risk tolerance. And what we've seen though across the spectrum is that the biggest risks, like tangible risks, when you think of major mining failures, things like that, happen in the operations side, right? That is the area where the biggest risks happen. And for that reason, that's also the area that is the lowest risk tolerance, right? They don't want
Right.
to take, we joke that most operating mines kind of want to be the first to be second, maybe the first to be third. They don't want to try something new. And so what we see is actually the biggest risk we see is that they're not necessarily getting all of the information. I mean, the biggest risk for a mine is not knowing all of the details or the history of the mine.
Mhm.
And that's a very broad statement. There's definitely other risks, right? I'm talking from a data geospatial side, underground mining, artisanal mining. There's a lot of risks in the mining industry. But from
Yeah.
the satellite side or the geospatial side, what we see the biggest risk actually being is not having all the information, not having all the history, and not knowing that they don't have it. So one of the things that we've really worked with mining companies on is,
Filling in
yeah,
those
filling
gaps.
in gaps, filling in those histories of saying, okay, my satellite data goes all the way back to the Cold War, right? There's a lot of data out there from the Cold War. Clinton actually declassified a lot of this data from the Cold War in the 90s. And so you can actually fill in a lot of gaps and say, okay, this is how the mine was constructed. This is where the water was. This is where the different materials were. This is where how the embankment walls were being built over time, whatever that might be. And fill in a lot of those gaps so that when you're making decisions today and you're building on top of decisions that were made 20, 30 years ago, you actually know what those decisions are.
It may absolutely does. And so it's not novel processes. Satellite data has been around, like you said, for a really long time.
Yeah.
Your services, is there a way to
Yeah.
demonstrate that there is a return on investment in the long run for mining operations? And is there any challenges for adoption on how we overcome these sort of doubts as to whether it's feasible or not?
When you talk about space-based data, satellite data for the mining industry, like I said, that as the whole spectrum of mining, there's a whole bunch of different things that you can do with space-based data. When you talk about risk, particularly, biggest risk, I believe, is actually data gaps, right? Not knowing what's happened in the past, construction gaps, history gaps. Um, Actual day-to-day operations is a whole other thing. One of the reasons why I don't consider that a huge risk from the satellite perspective is that operating mines are not quick to adopt new technology. Like I said, they're
Yeah.
first to be second, right? They're not quick to adopt new technology. It needs to be very well vetted. It needs to be proved out. It needs to have a lot of case histories, concepts, like all of these things need to be done for the operating mines, at least say the ICMM members, right? Like the big mines, whose names you would know. There needs to be a lot of data behind adopting the technology. The return on investment isn't necessarily around moving forward, reducing risk. There's some of that. Obviously, space-based data, you don't need boots on the ground. No one needs to be on site. You don't have someone driving a truck around your mine. There's space-based risks that get reduced just from being completely remote. The bigger thing on the return on investment is what data can you find out about what's actually happening, right? So if you're a mine owner and you have 20 mines worldwide, and all of the mines give you slightly different information because they're getting ground-based data. They have different operators, maybe different operators. They maybe have using different technologies. One of the things with space-based data is it can, because it's satellites, because it can shoot everywhere, it can give you the same information over all of your sites worldwide. So now all of a sudden you're looking apples to apples, right? So you can have a much clearer picture of what's actually happening. Same thing if you're a mining engineer that's, say, working for a consulting company and you're designing a tailings dam in your office in Vancouver and it's being constructed in the DRC, satellite-based technology can give you the ability to see what's actually being constructed. Is it actually being constructed to plan? It's sort of a third-party validation that does reduce the risk because now you can see, okay, it is actually being constructed. This is the material that's being used. This is where the water is. All of those information that you would need as a mining engineer, you can get that all completely remotely from a third party and validate your build to plan, reconcile what's happening.
PhotoSat recently launched the regional hyperspectral exploration targeting capability from space. From your perspective, what challenge in exploration does this solve in multispectral approaches that hasn't before?
Regional targeting from space, alteration mineral mapping has been happening for a long time. I mean, using the Aster data. And then, so that's multispectral data. So I'm not going to get super technical, but there's a certain
Sure.
amount of information you can find in multispectral. Aster had multispectral data. Worldview 3 has multispectral data. And now we have hyperspectral data coming in. So hyperspectral data gives you an order of magnitude, actually a couple orders of magnitude more information about what you're looking at. So if you had a mineral before and you didn't know what type of that mineral, what specific category of that mineral was, you can now, with hyperspectral data, pull it apart more to kind of unmix what's going on in that and say, okay, well, you know, this is actually X instead of Y. You can get much more specific. And that allows you to have a lot more accuracy in your geological modeling. So this data is all used by geologists to go into their geological models to say, okay, this is what we're going to be doing to narrow down our scope for our exploration targeting, and in a much, much more accurate way.
Yeah, it really interests me how because yeah, we can talk about the benefits of satellite data, but I'm just really curious about how PhotoSat manages this data, how you capture it. It must be tons of data. How are you executing like data analysis or data science? Or I mean, we were even talking about how we've been using machine learning and AI data processing for so long, Is there like a ecosystem or some sort of solution that you guys have for this data analysis?
When we first started looking at multispectral data way back when, 30 years ago, we were doing it the same way everyone else was doing it, right? Band ratios, things like that. We actually started bringing in convolutional neural network side of machine learning. I want to say, I'm just looking at the date right now. I want to say about 12 years ago. So we've been using it for a long time on both our survey product and our alteration project products. And one of the things that allows you to do if you've got a lot of training data, because as I'm sure you know, for any AI model, any machine learning model, your training data is what matters the most.
Key. Yeah.
Right. It's key. It's key. If you're training on bad data, you're going to get bad results and you're going to think they're good. And so, yeah, so the training data, we have 30 years of training data that we've been putting into all our models. And that's made it so that we also have a huge amount of ground truth data that we're putting into our models. And so one of the things that happens is that we said we've got some amazing customers. And so they'll actually send us for the exploration targeting product, they'll actually send us their ground truth data. So they'll go with their handhelds and they'll say, okay, this is our data we have over this site. You can feed it into your model, improve your model, and then give us back results with the improved model. So we're constantly iterating on the model, constantly improving it. And we've been doing that for over a decade. So when we think about what we have, yes, we have a really good algorithm. Yes, we have a really good model, but we have just a huge amount of training data that goes
Mm,
into it. And I
right.
think that really is the key, and not just to what PhotoSat's doing, but as AI comes more and more into our lives, is looking at how is it being modeled, how is the training data coming in, and how is it being validated? Because that's, I think, where people get a little lost.
30 years of historical data. That's great. I mean, you must have a great cloud environment for that storage, or is there any sort of cost of services or retrieval or any particular business challenges that Photosat is looking to overcome within this next year in particular?
When it comes to the data is huge. These data
Yeah,
sets are
I
massive.
bet.
Anyone who's ever worked with satellite data knows that they're massive. That's not really a challenge because other people have solved that challenge, right? The cloud has solved that challenge. Data centers, we have an on-site data center, we use external data centers. Data centers have
Amazing.
solved that challenge. Not cheaply, but they've done it, and that's fine, right? It's a big piece. I think when it comes to for us, when we're looking forward and saying, okay, a year out, what are the things that are challenges for the business that we're innovating on or that we're working on? It's all about being able to bring in different data types so that we can improve the answers to the problems that we're solving. So kind of swinging back to what I said at the beginning, for PhotoSat, one of our core values is always create value, a core value of the company. And so when we're working with a customer and say, for example, they're wanting to do bathymetry on their tailing site, can you do bathymetry from space? Sure, you can. Does it work really well in coastal waters where the water is clear and the surface underneath is bright white because it's nice and sandy? Yeah, that's where it works the best. So if you want to train space-based bathymetry on or space-based data to do bathymetry on tailings ponds, you actually need a vast amount of boat bathymetry data, lower, maybe it's, boats are the kind of the robots that they have for bathymetry. You need a lot of space-based optical data. You need maybe some multispectral data, maybe some hyperspectral data. But you need to be able to integrate as much of this data as you can to create the training data set, to create the model that works on the site. And and the interesting thing about that is you almost sometimes need to do it for every site because one
Hmm.
site might have completely different characteristics than another site. So we kind of joke in Photosat that the idea of that universal model that works everywhere is like the unicorn, right? Where it's like, it doesn't, for complicated problems, it doesn't really exist. It might exist one day, right? It
But
might
you
exist
chase it
one
anyways.
yeah, you for sure you chase it anyways. That's probably one of our top annual priorities every year is to find a universal model for something. So you definitely chase it, but you chase it with the understanding that while you're chasing it, you've got to use, maybe multiple models and put them together or patching certain things from different areas or bringing in different data. Like it's such a complicated problem that
Hmm.
I think that that's sort of one of the big areas of focus for everybody in the AI world.
Of course, we can definitely dive into AI a bit. If anyone's expert, you guys definitely are. Any particular data types that you're looking to to acquire like in this next year? Like, you said bathymetry. Is that one that like you guys are looking to acquire or anything in particular?
So, I mean, bathymetry is essentially looking at the surface underwater,
Mm-hmm.
right? So if you have, we're doing a few different bathymetry things right now, but say you have a tailings pond, you're going to have the water, you have the elevation surface going to, so it's easy, it's relatively, you can get the elevation of the above water surface, and then you hit the water, and then figuring out what's continuing to happen under the water is what bathymetry is. So it's modeling the surface underwater.
Curious, are we doing deep sea mining or like anything
So
particular like
we're
that?
so so people are we're not doing deep sea mining stuff yet, but we're looking at things like bathymetry underwater for tailings facilities. We're looking at
Okay.
underwater bathymetry for pipeline monitoring. So especially after flood events, what's actually happened to the ground around the pipelines? Is the ground becoming exposed? Like, is the pipe becoming exposed? Things like that, or is there a threshold of tolerance? So this is all more on the safety, like especially post flood for pipelines, and then for tailings it's more around like what's actually happening underneath the water, so they know where they need to pour more material, where they need to deposit, what their angles are like, their volumes, all those things. So that part's like ongoing. They need that information fairly regularly.
Yeah,
So when we talk
nice.
about bathymetry itself isn't a data type, but there's a bunch of different data types that can go into answering the bathymetry question. What types of data are we excited about, or are we trying to get our hands on more of? It would be very excited about hyperspectral data. I mean, hyperspectral data is very powerful. Thermal data, especially multi-band thermal data, really interesting. There's some interesting problems people are asking us to look at around things like, can we determine if there's water seepage happening on a mine site under ice?
Hmm.
So if you think about that, it's like if you're in the Arctic, we have a lot of ice in Canada. If you're in the Arctic, or if you're in the north and you have a mine site where water is seeping somewhere it's not supposed to be seeping, but the whole ground is covered in snow and ice, how do you determine if the water is actually seeping, right? You potentially could do that with thermal data, where you're looking at small gradient changes in the surface of the snow to say, okay, well, this might be where water's seeping, or this might not be. So there's a bunch of really cool problems. And one of the things I do want to point out is our customers typically have no idea, nor do they care about what data we're actually using. Because oftentimes I mean, they might care from like an interest sake, but they want to know, what are the results?
Yeah.
Does
Oh
this
yeah.
work? Can you prove it? Can you validate it? That's, I think, one of the things where sometimes people come into the geospatial side of the field, especially the space side, and they're like, oh, but space is cool and everyone should care about how cool it is. And some of us really do, but the customer doesn't necessarily care, right? The customer wants to know, is it doing what I need it to do? Not, is it hyperspectral or multispectral or 30 centimeter data or 50 centimeter data or color data or multiband data. They don't necessarily care. They care about, is it giving me the answer to the question that I'm asking?
Hmm. Oh
And
yeah.
that's really what we focus on. So I can geek out about the data all day, but I almost never
Yeah.
talk about it.
It's true. I mean, with something that we always talk about also. Okay, we're in remote places, right? High
Yeah.
altitudes. It's dangerous. Smells bad. Like chiseling rock away. Like why? Because we love rock. Because we love the scenery. No, we're just here
Really
to
like
make a
hiking.
profit. I mean, I guess we do like hiking, but no, we're here to make a profit. This is data architectures and cloud engineers. We love like the whole conversation of data and like automation and lineage and all that. But so we come across some of these industry leaders who these guys have multi minds. They're making millions of dollars a month, but they don't really care about AI or how it works or really how like this all this stuff works. They just care about how can I get more investment, or how can I reduce the downtime, or this and that? How can we get to the results, basically? It's very true. I mean, we can geek out on the podcast all day about space and hyperspectral and data, but just from your perspective, is there any particular actual necessities or priorities, like in data lineage or governance or traceability, where artificial intelligence could truly play a role in mining operations?
Well, I think there's going to be a huge amount of areas where AI machine learning. I mean, I'm talking more around the convolutional neural network side of machine learning because that's what I understand the best. But you look at the trends in mining, the trend toward autonomy, right? Autonomous vehicles, autonomous operations. AI is going to, I believe, play a huge role in that. There's kind of an infinite number of areas as to how. I think the governance question is interesting because there's two sides of governance that I see. There's the mining operations governance, right? If you look at your tailings management governance, the global tailing standards, you look at your local governments, there's the governance, there's a whole bunch of things where I think AI can really help with managing the huge amounts of data that these sites are generating and that companies like my company add to the pile of these huge amounts of data to really filter through it and create a good understanding of what is actually going on, triaging what areas need to be looked at. Like there's going to be a big part of that. I think when I think about governance and AI, I actually am more concerned about the claims companies using AI make about what they can do.
Hmm.
That's the thing that concerns me from the because there's really no real governance in AI, right? Like it's sort of the Wild West. People can do whatever they want to do. They can say kind of whatever they want to say about it, and a lot of people don't understand it enough to know what the right questions to ask are. And so I see this a lot. You know, I see this a lot, particularly in areas where there's new technology or where people are saying, "Oh, we're making these claims. We have an AI model that can, have this accuracy of 95%." It's like, cool. How are you validating that? How are you actually showing that that's true? Do you have any case studies? Have you had any third party actually look at it and agree with you? Do you have any customers that have provided ground truth that have validated what you're doing? Like, there's a whole bunch of pieces on the claims side that I see that really concern me because I think one of the things is that it feels a
That's
little
okay.
bit like the people out there like selling snake oil with AI being like, oh, well, we use AI, so you should trust us. And it's like, no, no. AI is, first of all, it's only as good as the training data you have. You have bad training data, you will get bad results. And if you're not validating those results, you don't know that they're bad. And if you say, oh, well, it shows one of the things I see happen is that people will use a small training sample or not great training data that's inaccurate, and then release a paper where they've taken a data set they trained the model on. So a piece of the data that they trained the model on, they'll afterwards take it out of the model, or not take it out of the model, but take that data set, put it back through the model and say, see, we got the results that we thought we were going to get. And I don't know if it's quite obviously, like, I know you know a lot about AI, but I think a lot of people don't realize that if you're using your training data as your validation data, you're not actually validating your model. You've got to use completely external data, something that's never run through your model to say, okay, are we getting the results that we can verify and validate? And that's the thing that I see a lot of people saying when they're marketing AI or when they're talking about AI. And I don't think the general consumer really understands how that works.
It's true, and it is like the wild wild west. It really is,
Yeah.
and
And there's no governance
it's
in it.
It literally no governance,
Yeah.
and I think it's the consumer doesn't know that anyone can claim that they have like an AI. We use AI in our workflows, and people are like, "Oh, AI, how do you, it just sparks the interest." And unfortunately, there's not enough knowledge to actually understand what's happening in the back end. And it's just kind of scary how like we really have no idea what's happening there. Across your journey or your paths, have you found or come across anyone who has had correct claims ever in the past? A 95% like accuracy, or ever come across anything
U-
like that?
using exclusively AI?
Yeah, yeah, using exclusively AI.
Yeah. No, I haven't. Not
Incredible.
nothing, not someone who has something published.
Incredible. Yeah, imagine that.
I have seen people who, because I go to a lot of conferences and see a lot of technical papers, and I've definitely seen technical papers at conferences where they are using some AI, non-generative AI is sort of what the engineering world prefers because it doesn't make things up. So non-generative
Yeah,
AI.
yeah.
And they've said, yeah, the model has maybe of the points that we looked at, this is the accuracy. But it's not this overarching claim of, oh, we have 80% accuracy all of the time. Like, how do you even
Hmm.
measure that? How do you know that, right? So I have seen some really good papers where they're looking at specific points and they're saying, okay, on these specific points, this is the result that we received. And those are really well done. Those aren't typically done. I mean, that's not corporate marketing material. Sometimes it's companies that do it, like PhotoSat's done some of those studies as well. Those kind of big splashy claims, I've looked into a few of them when I see them and they get sent to me and people are like, oh, is this accurate? And when I go on those companies' websites, typically I can't find a single case study. I can't find a single paper that's been published. I can't find anything to substantiate it. So it's really easy to
Yeah.
say something if you don't have to substantiate what you're saying.
Probably the best you'll find is like these like YouTube videos of like who knows who, like random people saying like, "Oh yeah, like it works," or this and that, like I
Mhm.
am proof that they did give me X amount of clients or anything like that. No, yeah, yeah, of course.
Yeah,
Uh
and I mean, and I think Photosat understands that pretty well because when we first, so our one of the things about Photosat is one of our main products is really high accuracy topography from space, right? So elevation modeling from space. Our accuracy is about 10 centimeters vertical accuracy. So that's essentially telling you if something is that's the same vertical accuracy as say the road to the curb or like the size of your iPhone or your phone if you're not an iPhone user. That's about 10 centimeters.
hmm,
And historically, the best accuracy you could get from satellites, it used to be 50 centimeters. And so when we didn't start at 10, we started at like 30 when we first kind of started using our different algorithms
incredible.
and processes. But when we first at a conference, Jerry said, yeah, these are the results of what we're getting. Someone stood up in the crowd and I think he was a professor, he's retired now, and said, that's impossible. You can't do that. It's impossible. And Jerry, being the stubborn geophysicist that he is, ended up releasing 21 accuracy studies of individual, like independently verified points to say, no, this is actually what we're getting, right? So that wasn't, we were actually at the time starting to use some convolutional neural networks, but we weren't talking about AI. No one was talking about the AI side of it, but we were doing something fundamentally different from what you could do before. And nobody understood how we did it. We didn't really want to tell people how we did it because that was our competitive advantage.
Oh
So
yeah.
instead, what we did is we found different regions of the world where there was independently verifiable ground truth and said, okay, we're going to do this over that and have a third party assessment of how close we are to those different points. And so we published, yeah, it's like 21 accuracy studies over the next few years. And that's the type of rigor and stubbornness that I don't see happening in these AI companies, where you say, hey, you don't have any case studies. And they say, oh, no, we're too busy so far. We haven't had time yet. And
Mhm.
it's like,
Yeah, yeah.
that makes me suspicious, skeptical, just skeptical more than suspicious.
It's a new industry, and well, I guess for you guys. you've been doing using AI machine learning for a really long time, but it's just been open up to the public. So we're seeing all these AI startups just come up, and yeah, maybe there's still like free revenue or anything like that, and they
Yeah.
can't sustain what their claims. But hopefully,
And they don't even try, which is the weird thing to me.
yeah,
And in
yeah.
the mining industry, I don't think that's really, in the operating mining industry, I don't think that's going to fly. The operating
Mhm.
mine industry, very risk adverse, doesn't want new technology that isn't proven out. If you want to get into that space, you need to have case studies, proof of concepts, customers that are working with you on developing something and feeding back to you. Is it working? Is it not working? Do your models need to be adjusted? Like that in the operating side. The exploration side, a little bit more of the Wild West. I just had someone reach out to me a few months ago. They had received a report from someone who said it was generated by AI. It was a geological product where they were saying they could quantify the amount of a deposit using free satellite data. So why they reached out to me, because it was all satellite data. And they paid good money for this report. They paid like $10,000 for this report. And it was, as far as I can tell, absolute nonsense. And
Mhm.
I sent it to Jerry he's retired now, but I was like, "Hey, you're a geophysicist. This is your world. What do you think?" And he was like, "No, snake oil. Like not a thing." But people don't know and they don't how to verify it or validate it. And so I feel really bad because people are spending their budgets on things that don't make sense and don't work. And but because it was generated by AI, it doesn't matter that the pixel size was too big to actually see anything, or, the type of satellite they were using doesn't have a sensor that even picks up on the thing they're looking for. Like I don't know, it's a little,
Or data has been like just
it's a little
randomly
unregulated.
generated by them, like just like hallucinated additionally. And
Yeah, it feels a
that's
little bit
true.
like a hallucination. And there's no one to hold any of that really to account, which is also the challenging piece. Yeah, you can tell I'm passionate about this part a lot.
It
I have
has to be, you
a
have
lot
to
of
be, of
passion for
course.
this. Yeah, I've also had people say, "Oh, well, we've tried satellites and it was wrong, so it doesn't work." And it's like, "Oh no. It's not that you tried satellites. You tried a company that was selling you snake oil, and that's not the same thing."
Mm. It works though. They're selling it, but there has to be a filter, there has to be someone actually looking at the data before it goes on to the next process. It can't just be completely generated. And because then who do you
Yeah.
hold accountable, Really, I
There,
mean, it is us who are hold
yeah.
accountable.
And and
So,
and there, yeah, there has to be a QC stage. I
yes,
was at
absolutely.
probably 8 years ago. I was at a talk with someone who was starting. They had a company that was starting to look at building footprints using AI, and and he said in that talk, and I'll never forget it. He said, if anyone tells you they're doing AI and there's no human intervention at all and no QC, do not trust what they are doing. And that really resonated with me because that was the same belief that I held, but I hadn't
Hmm.
heard it before. And this was before people were really talking about AI very much. Like this is sort of at the beginning. And so I feel like people who have been doing this for a long time know that. They know that you can't, you know, if you're not QCing, if you're not looking at it, models get things wrong sometimes.
All the time.
Um,
Yeah, sometimes
all the
yeah.
time.
All the time, yeah.
like it's
Been
you
conservative.
know
That's
yeah, one
every
I
now
mean
and
one of the
then.
challenges we have is looking at water on mine sites, right? We do a lot of work around looking at water, and you want to train a model to identify water on a mine site in northern Canada, and you're trying to say the model is never going to get it wrong between mud, muddy water, and water
Ice melting
with
in Canada.
all and ice melting and and all the different angles the data is coming from with glints and glares and different weather conditions. Like there's
Oh
no
yeah.
way that it's not going to be sometimes getting it wrong and needing to have someone go through and say, does this make sense, does this not make sense? And maybe one day the models will get to that point, but we've been doing this for a long time. It's not there yet, at least not for complicated problems, right? If you want an
Yeah.
AI to tell you that a picture of a dog is a dog, unless you've got a pug, was that dog, pig, loaf of bread in the movie? Unless you've got a pug, you're probably going to be right that it's a dog. But if you're looking at these complicated water, mud, muddy water, those are complicated.
I can't imagine. Yeah, I mean, when we put it that way, the glare from like the light reflecting like that, how is that even possible to be so accurate? How could it be so accurate, you know? And how could we claim for it to be so accurate? And there has to be a QC, someone there checking it at all times, especially with the mining industry where we're talking about real lives. If someone wanted to learn more about your services, check out PhotoSat or even get in contact with you for any way, what is the best way to contact you, or how can someone learn more about PhotoSat?
I mean, we have our website is photosat.ca. So we are in Canada, so it is .ca.
Oh, very
And
nice.
so that would be if you want to look at, we have a resource library on our website where you can download case studies, you can download accuracy reports, previous technical papers that we've written. So if you're curious about, okay, how is a company, even if it's not necessarily what your listeners are interested in, how is a company actually validating their results? What kinds of things are they doing? You can take a look at some of the things we have on our website there. Also has our contact information. I think for me directly, contacting me through LinkedIn is probably the best way to get through. I get about 100,000 emails a day. So
Exactly.
email is not the best way to get to me directly, but LinkedIn is, I'm pretty good at keeping up on what's going on there.
And thanks to you, Andrea, for being on this call with me. And thanks to our audience for listening. And it's been a pleasure having Andrea here with us. And we'll see you all in the next one. Thank you so much for being here with us, Andrea.
Thank you. Thank you for having me.